I want to show you a couple of harder examples of how to use elimination to solve simultaneous equations. Here's the first one. X minus 5y is negative 17 and 2x plus 3y equals 5. Now, if I say elimination, then I'm looking for two equations which have the same coefficient for at least one of the variables. But these two equations don't. However, it's very easy to change them a little bit to make it happen. In particular, notice that this is 2x and this is just 1x. So let me label the equations. And if I multiply the first equation by 2, then I'll have 2x in front. But if I do that, I'll have to subtract, and I'm going to be subtracting with negatives, and it might be very confusing. So, like I did in the last video, I find this is probably easier. Multiply this first equation by negative 2 so that you get opposite signs for the x. So negative 2 times equation 1, negative 2x plus 10y is positive 34. Negative 2 times each of those. I'm going to call that 1a. Now equation 2 hasn't changed. I'm going to rewrite it because I find it easier to look at it that way. Equals 5. And then I'm going to add 1, that's a mess. I'm going to add 1a and 2. Pardon me. So this goes away. Negative 2 plus 2 is 0. 10 and 3 is 13y. 34 and 5 is 39, which means y must be 39 over 13, which means y is 3. Okay, substitute that back into one of the equations. Equation 1 is probably the simplest. X minus 5 times y is 17. Sorry, negative 17. I'll get the negative 17. X minus 15 is negative 17. X is negative 17 plus 15, which means x is negative 2. How can I check that? Use the other equation. Check in equation 2. 2 times x plus 3 times y has to be 5. Negative 4 plus 9 is positive 5. Correct. So my solution is x equals negative 2, and y equals 3. Let me show you another one. Okay, so here's the next example. In this case, neither equation has the same coefficient of any of the variables. But I still think this is pretty easy to solve with elimination. Yes, you could do substitution, but you're going to end up with halves, thirds or quarters in your equations. Elimination does avoid that. So, unless, of course, one of your answers has a fraction in it. So here's what we do. I need to make one of the variables have the same coefficient. It doesn't matter which one, I've just got to have the same coefficient. And for ease of adding my equations, it'd be nice if they had opposite signs. So if you look at y, they've already got opposite signs, but how can I make the coefficients the same? Well, it's actually very like fractions. If I multiply the 3 by 2 and the 2 by 3, I'll end up with 6y on both equations. Let's try that. 2 times equation 1 and 3 times equation 2. I actually find it helps me to write my strategy first, because then once I've done one of them, I know straight away what I have to do for the other. I don't have to pause and think again. So, 2 times equation 1 is 8x plus 6y equals negative 14. That's 1a. 3 times equation 2, 9x minus 6y equals 3 times 16 is 48. 2a. Now I can just add them. 1a plus 2a, and my y's will be eliminated. 8 plus 9 is 17x, y goes away. 48 take 14 will be, let me think about that, 38, 34. Does that sound right? Yes, it does. If you're stuck, you can always get your calculator. 48 take 14, correct. All right, 17x is 34, x must be 34 divided by 17, which means x is 2. Okay, substitute that into one of the equations. They're about the same, pick one. So 4 times x, which is 2, plus 3y is negative 7. 8 plus 3y is negative 7. 3y is negative 7, take away 8, which is negative 15. So y must be negative 5. Okay, how can I check that? Well, I substituted into 1 to work out y, so I need to use the other equation, number 2, to check it. Check 2. Let's see, 3 times x minus 2 times y minus 2 times y has to be 16. 6 plus 10 is indeed 16. So therefore my solution is x equals 2, y equals negative 5. So just to go over that one last time, you look at your equations, you try to multiply each one by something to get the same coefficient, preferably with opposite signs, so you can just add them together.